All right, so you guys are going to need your identity sheets and your own paper for this lesson. So this is going to be lesson 5.1b, and we're going to be factoring trig expressions. So in the previous lesson, we did a factoring problem, and you guys had some to do for your homework, but this lesson is going to focus on factoring and then simplifying after you factor. So you're going to get a little better at it today. So for example 1, we're going to factor each expression and simplify if possible. Right? So on these today, we aren't going to have the matching, so it's a little bit more difficult to know when to stop. So it really just comes with experience, that you know when you've simplified it as much as possible. So let's look at A. For A, we have a fraction. Our numerator is sine of x plus cosine of x, and our denominator is sine squared of x minus cosine squared of x. All right, so just remember that the lesson is on factoring, so we're definitely going to factor every one of these today. The numerator is on this one is not going to be able to factor, so we just leave it like it is. The denominator is the difference of squares, which is the one type of factoring that we did practice in the previous lesson. So we'll do our parentheses, and then we find each square root and do one with a plus and one with a minus. Sorry, I had to squeeze that in there. So it's sine of x plus cosine of x, and then sine of x minus cosine of x. Okay, and then hopefully you guys can see that there is a sine of x plus cosine of x in the numerator and in the denominator. And whenever that happens, remember they have to die. So you cancel them out when they look exactly the same. And then if everything cancels out of the numerator, there's a 1 up there. And then what's left in the denominator is sine of x minus cosine of x. And that's all you can do. You're done at this point. Okay, so let's look at another one. That one, we didn't use any identities. We just basically used algebra with the trig functions. All right, so for B, we have cosine squared of x, cosecant squared of x, minus cosine squared of x. Now, one thing that we do a lot with this factoring is factor out a common factor. That is super, super common. And so what we have here is a situation where we are going to factor out a common factor. So we look at, there's actually two terms. One is in front of the minus sign, and then one is after the minus sign. And so what we're trying to find is what those have in common. And what they have in common is cosine squared of x. So we're going to factor it out of each of them. So when we factor it out of the purple one, we're left with cosecant squared of x. And when we factor out the green one, it completely factors out. So when it completely factors out, it leaves you with a 1. Right? And this one we are going to need to use an identity. So anytime you have like a square term and a 1, or a square term and like a plus 1 or a minus 1, you're probably going to use a Pythagorean identity. And that one looks similar to number 11, except that it has been manipulated where the 1 has been moved over with the cosecant squared of x. And so that cosecant squared of x minus 1 should be equal to cotangent squared of x. Okay, and then we could keep trying to see if we can simplify this more. Like, for example, we could try to use number 8. And if we did, we would multiply by cosine squared of x over sine squared, and nothing would cancel. Like, if it had been a tangent squared, we definitely would want to use number 7, because then you could see that cosine would cancel. But it's just not going to make it any simpler if we change it to a fraction. So this is it. This one is finished. I know it doesn't feel like it should be, but it actually is as simple as we can get it. All right, so let's look at another one. For C, we have cotangent cubed of x plus cotangent squared of x plus cotangent of x plus 1. Okay. Now remember, this lesson's on factoring, so we're going to factor every one of these. And if we were talking about polynomials, this one would have 4 terms. And so if you guys remember, when we factor with 4 terms, what we want to do is factor by grouping. So we group the first 2 together and the last 2. And then we're going to factor out a common factor. In this case, our common factor in the first group is cotangent squared of x. All right, and then the second group doesn't have a common factor. So when there is nothing, we will make sure we put a plus 1. Okay, and then if you guys remember, what we factored out becomes one of our factors in our final answer. And then these 2 need to be the same, and they are, and they become the other factor. Okay, so now we want to go to our identities. So look at your identities, and whenever you see a squared and a 1, we're definitely going to look at the Pythagorean identities. And cotangent squared plus 1 is the same as 1 plus cotangent squared. So that should be equal to cosecant squared of x. All right. And then there's always people that want to use that one for cotangent plus 1 and say that that's just cosecant, like drop off the squares. You cannot do that. So a lot of that's a really common misunderstanding. But we can manipulate a lot of these identities, and you can manipulate the Pythagorean identities, but not with the powers. So with these 3, the manipulations that you do can only be like move addition or subtraction, moving things to the other side of the identity, not changing the powers. The powers are like locked in on those. Okay, so let's look at another one. Let's look at D. For D, we have cotangent squared of x plus cosecant of x minus 1. All right, now we want to factor this, but the way this is written right now, we can't because we have cotangent squared and then we have a regular old cosecant. So that's not going to quite cut it. So what we're going to have to do is change cotangent squared, preferably to a cosecant. So if I look down here at number 11 and I subtract that 1, I can replace cotangent squared of x with cosecant squared of x minus 1. Okay, so all of that is what cotangent squared of x equals. All right, then I would combine my like terms. So the only like terms I have are these minus 1s. So now I am going to factor this like a trinomial. So what I put here and here needs to multiply to give me cosecant squared of x. And that is going to be cosecant of x and cosecant of x. Right? And then I know, because of this subtraction sign, that my signs are different in my factors. So one will be a plus and one will be a minus. And then what I put here and here need to multiply to give me 2. So I know that's going to be 1 and 2. We just have to figure out where to put the 1 and where to put the 2. All right, because I want a positive cosecant of x, I would put the 2 here and the 1 there. Now, if I multiply that back out using double distributive property, I would end up getting this, which would simplify down to the original. Now, those, we can't use an identity to change anything. You might think you could use number 11 again in some way, but you can't because it doesn't have a squared. So to use those Pythagorean identities, they have to be squared terms, and they're not here, and this is it. That's all we can do. So that one's a little different because we used identity first and then factored, when on the other, some of the other ones we factored and then used an identity. Okay, one more. For E, we have 6 cotangent squared of x minus 13 cotangent of x plus 5. Okay. This one's kind of like D, but luckily at the beginning, all we have is cotangents, so we don't have to worry about an identity first. We can go ahead and factor this like a trinomial. Now, the factoring part is a little more difficult on this one because what I put here and here needs to multiply to give me 6 cotangent squared of x. So we have choices. It could be 6 cotangent and 1 cotangent, or it could be 3 cotangent and 2 cotangent. And so you really just have to make a decision, like which one you want to use. And if it works, then you guessed right. If it doesn't work, it's okay. You just try the other one. All right, so think about what you would do. And I am going to do 3 and 2. Now, there is no way to know until you try it, so don't worry. Then on this one, because this sign is positive, I know that my signs are going to be the same, and then this one tells you what they are. So 2 minus signs. And then what I put here and here needs to multiply to give me 5. And the only choices there are 1 and 5. So we just have to play with it to see where we would put the 1 and where we would put the 5. So we end up with a 13. And if we don't, if there's not a way to do it to end up with a 13, then we would try 6 and 1. But there is a way. If I put 5 here, that is going to give us negative 10. And then I would put the 1 here, and that would give us our negative 3. And they would combine to give us our negative 13. So that's right. All right, and then these, there's nothing we can do. There's no identity that works with these numbers. So that's it. Okay, so your assignment, we're still on page 355. I want you to do 22 through 32 even.